Welcome everybody. Today's lesson is all about solving equations with radicals. Before we can get into actually solving some equations, we need to review some of the rules of roots. First of all, over to the right, I've outlined a couple simple rules. Odd roots of negative numbers are okay. Even roots of negative numbers are bad news. That will give us no real solutions. So again, I'm allowed to take the odd root of a negative number, not allowed to take the even root of a negative number. We learned about that when we studied power functions. Let's look at a couple examples just to freshen our memories. Example number 1 asks us to write -5 to the -4th power times -5 to the 7th power without exponents. Remember from our power rules that a negative exponent moves to the denominator, so I can rewrite this as -5 to the 7th power divided by -5 to the 4th power. You'll remember that we need to subtract our exponents when the bases are the same, so this gives us -5 to the 3rd power, which gives us -125. In example number 2, I'm asked to find the 5th root of -32. This is all right because I'm taking the odd root of a negative number. This will give me -2. In example 3, I'm asked to simplify the 3rd root of -1250. We want to break this down into two factors, one of which I can take the 3rd root of. Let's break this down into the 3rd root of -125 times the 3rd root of 10. I know that the 3rd root of -125 is -5, and I'll leave the 3rd root of 10. There, my answer is simplified.
That was easy.
Last one, example number 4. I'm asked to simplify the 3rd root of -8a to the 9th. I can take the 3rd root of -a since it's the odd root of a negative number, and I get -2. I'm taking the 3rd root of a to the 9th power, which is basically just dividing those numbers, so I get a to the 3rd power as my final answer. So -2a to the 3rd power. Now you try. Try the on your own questions and then check your answer. Alright, for question number 1, the 5th root of -243 is -3. For question number 2, I can find the 3rd root of -27 as -3, and I'll add that to the 5th root of -1, which is -1. Together I get -4. Question 3, the 3rd root of -27 again is -3. I'll multiply that by the 3rd root of -64, which is -4. And together I get 12. Now I could have done that a different way. If I had multiplied -27 times -64 and taken the 3rd root of that, I would have still gotten my same answer of 12. Alright, question 4. I want to break this down into the 4th root of 16 times 2, and I'm going to do that because I can take the 4th root of 16, and then I'll break n down into n to the 12th times n. So my final answer after taking the 4th root will be 2n to the 3rd times the 4th root of 2n. If you missed any, go back and check your work. Now we're going to move on to actually talk about solving some equations with radicals. Before we can do that, we have to talk about what are called extraneous solutions. Extraneous solutions are solutions that we get when we solve, but when we plug back in to check our answer, it is not a solution to the original equation. This often comes when we're talking about radicals. So, when solving each of our equations, we'll have to plug our answer back into the original to make sure that it works. Let's turn to the back and try the first example. All right, in solving example number 1, I'll subtract 5 from both sides, and I'll get negative the 6th root of x equals 3. Multiply both sides by negative 1, and I'll get the 6th root of x equals negative 3. To undo the 6th root, I'll raise it to both sides to the 6th power, and I get x equals 729. Now, it's time to check our answer. I'll plug 729 back into the original equation. 5 minus the 6th root of 729 equals 8. 5 minus, and the 6th root of 729 is 3. That's supposed to equal 8. Well, we get 2 equals 8. Uh-oh, that's a problem. This is what's called an extraneous solution. We can see where the problem came. Back here, I had the 6th root of a number was supposed to equal negative 3. I know that I can't take the 6th root of a negative number, so this right here told me my solution was not going to work. This tells me that there are no real solutions. Let's look at example number 2. To solve, I'll divide both sides by 2, and I get 6 equals the 4th root of m. To undo the 4th root, I'll raise both sides to the 4th power. I get 1296 equals m. Let's check our answer. 12 equals 2 times the 4th root of 1296. 12 equals 2 times 6. 12 equals 12. Woohoo! We got the right answer. 12 is in fact our solution. There are no extraneous solutions here. All right, example number 3. I'm going to have to subtract 25 from both sides. I get the 5th root of g is equal to negative 15. I have to raise both sides to the 5th power to undo the root, and I get g is equal to negative 759375. Now it's time to check our answer. I plug it back in. 25 plus the 5th root of negative 759375 equals 10. 25 plus, and remember, I can take the odd root of a negative number, so 25 plus negative 15 equals 10. So 10 equals 10. It checks out, so g equals negative 759,375. All right, now it's your turn. Try the on your own questions, and then be sure to check for extraneous solutions. All right, for question number 5, you should have subtracted 12 from both sides, gotten negative the 4th root of x equals 20. Both sides need to be multiplied by negative 1. So the 4th root of x equals negative 20. Raise both sides to the 4th power. So x equals 4,096. Now, it's time to check our answer. But first of all, I made a big mistake. I made a mistake back when I was solving. I didn't subtract 12 from both sides. So it should have been negative the fourth root of x equals 8. When I multiply both sides by negative 1, the fourth root of x equals negative 8. Now when I raise both sides to the fourth power, I get 4,096. Now, when you check your answer, you should have seen that this is extraneous. That means there's no real solutions. All right, for question number 6, you should have squared both sides to undo the root. 8x minus 3 is equal to 16. X then equals 2.375. When you check your answer, it should work. Last one is number 7. All right, we're subtracting 3 from both sides. So negative 1/2 the sixth root of w equals negative 8. I have to multiply both sides by negative 2. So the sixth root of w equals 16. Raise both sides to the sixth power. And w equals, this is a big one now, 16,777,216. If you plug this back in, you'll realize that it does check out. So your final answer is 16,777,216. All right, we'll save those last 2 problems for class. Hopefully, solving equations with radicals and extraneous solutions are making sense. Come ready to ask questions.